My dear students, welcome. So this is Dr. Lonathan. I am taking the class, the mechanism of solids 1. So first we have to visit the simple definitions. So first, what is meant by stress? So stress is the internal resistance offered by the body to the external load applied to it per cross-sectional area. That is the internal resistance offered by the specimen or the body to the external loads. So what are the external loads? So the loads are different. The compressive load, tensile load, shear forces, or compressive forces, tensile forces, etc. So this is the loads or forces. So this is called this is the simple definition. This is in the mathematically stress is equal to load by area. So the unit is the Newton per mm square or kg per centimeter square or kilonewton per meter square, so etc. So this is the unit. So stress is the in the mathematical definition is load by area, P by A, sigma. So the notation is sigma, which is equal to load by area. Next, what are the types of the stresses? First one, compressive stress. Second thing is the tensile stress. Third one is the shear stress. So what is the compressive stress? Compressive stress is nothing but that means the compressive force by area, that is called compressive stress. So compressive force or compressive load by the area, that is called compressive stress. So next one, tensile stress. So tensile stress is, that means the tensile force by area, that is called tensile stress. So next, the shear stress. So shear stress is the ratio between shear force by that area, which is called shear stress. So we can see the diagrams, so which offered so your representations. So compressive stress. So this is the compressive force. So this is called compressive force. So pressed some specimen or load body. So pressed like this. So this is called a compressive force. So compressive force by the cross-sectional area or load applying area, which is called compressive stress. So this is the specimen or the body. The specimen receive the forces, that is the compressive forces. So pressure given to the body, that is called compressive force. The compressive stress means compressive force by that cross-sectional area, which is called compressive stress. So next one, the tensile stress. So tensile, first, what is meant by the tensile force? The tensile force is the force and in the particular body, so pull action. So this is the tensile force. This arrow mark like this. These forces are pulled the body. This is called a tensile force. So what is meant by the tensile stress? The tensile is stress. That means the tensile force by the cross-sectional area. That is called tensile stress. All right. So what is meant by shear stress? So shear stress is nothing but the shear force by the area. That is called shear stress. So see this diagram, the particular body, so particular structure. So we have to provide the force. So the body will be deformed like this. So this is called shear stress. So shear stress means that the shear force by the area. So that is called shear stress. Right. Next one, the strain. So what is meant by the strain? Strain is the deformation of material from the stress. It's simply the ratio of change in length to the original length. So this is the simple representation diagram. So this is the rod or bar. So this is the original length. So that is forces are not acted. So this is simply present in the presentation in the particular area. So the forces are not acted. So here, so uniaxially loaded rod or uniaxially loaded bar. The forces are acting like this. So this is the tensile force. So this is called a tensile force. That is, it is denoted as P. So while presenting the tensile force, the rod will be deformed. The deformed length, it is called, so this is del, that is, or change in length. So the strain is equal to change in length by the original length. So this is the change in length. The particular length is change in length by the original length. So what is the original length? So this is the original length. While the free rod, it is called free original length. While acting the particular forces, that is the tensile forces acting on the body, the rod will be turned like this. So this is the change in length. If you given the compressive force, so it will be contracted. So this is expanded. So if you provide the tensile force, the rod will be extended. If you provide the compressive force, the specimen will be contracted or shrinked. So, however, so this is the strain is defined as the ratio between change in length and original length. So which is called strain. The mathematical presentation is the strain is equal to change in length by original length. So it has no units, right? Okay. Thank you.